So in this video, I'm going to write a constraint which ensures that there won't be two consecutive write operations. That is, that there won't be a write operation after a write operation. So let's begin. So instead of creating an RTL for a RAM, I will just, for the sake of the example, I will just declare an enum variable, and that enum variable will have two possible values. Those are read and write, and I will name this RW, that stands for read and write. So I will declare this inside a class, and let's name this class trans. So this enum variable will have only two possible values. Those are read and write. So I have to write a constraint which will make it sure that uh, it will not get two consecutives right. So let's begin. So to do that, I will just declare two enums. So first one, I will declare it with rand keyword so that it could be randomized, and type is RW. So I will write RW and RW underscore A. So I will write another enum variable, and that will not be randomized, and you will get to know why. So I will name it RW and old. So I will use this particular enum variable to capture all the previous values which this will get after randomization, and it will track a record, and then it will compare it. It will be compared to the current value to make it sure that whether it has received a write operation previously or not. So first I will write a constraint. Just a second. And let's name this rw underscore c. So in this constraint, what I will do, I will just write a condition using implication operator. You could also use if you want, and that condition is going to be very simple. It is that if the old value of the of this if the old value of this enum variable is right, then the current value could not be right. So the constraint is very simple, that this will represent this enum variable will represent the old value of this variable or this enum, and if the old value or the previous value was right, then this time it should not get right, and this is just to avoid getting consecutive writes. But how the question is that how can the rw underscore old catch the old values of this rw underscore a? So to do that, we are going to use one of the method of randomization, and that is post randomize. So I will declare a function and this method is implicit with randomization. So this method is inside the libraries. So what this does, just a second. So what this does, anything that is mentioned inside the post randomize will happen after the randomization is done. So what I want to do right here is that I will assign the old RW old with RWA. So this will be the overall flow. This will be the flow of the code. First, the RWA will be randomized, and then the all the things will happen. The constraint check will happen. Since by default the RWA will have RW old will have no value, so the constraint will just the constraint does not matter in that case. So what will happen? First, the RWA will get a randomized value, and only after it gets the randomized values, uh, that particular value will be assigned. So the randomized value will be assigned to RW underscore old. Then after that randomization, during the next randomization, what will happen that RW old will again get the randomized value as per the constraint, and in this constraint the value will be compared. So since we detected the previous value in the previous randomization run using this post randomized method, and we captured that value inside the RW underscore old method, this constraint will check whether the previous value was right or not. If it was right, then the RW underscore a will not get right and it will get read. So using that constraint, we can make it sure that there won't be consecutive write. So let's find out whether it works or not. So I will declare the module, and in that uh, first what I will do, I will just mention this inside a package instead. Which will make it easy to import all the labels of the enum variable. So I did nothing. I just put everything of I put the entire class inside the package, and I mentioned the enum variable inside the package instead of inside the class. So very first thing I will do is that I will just import uh, all the labels using the wildcard import. So this will also import the labels with the enum variable itself. Now I will declare the handle of the trans class. After that, I will begin with my initial block. And inside that initial block, first I will assign an object to that handle. And then I will create a loop that will repeat for 10 times. So it will repeat for 10 times, and each times it will just randomize. So I will write assert randomize, and if the randomization fails, I will get an error. So after each randomization, I will just use the display system task to print the value of the rw underscore a enum variable. And since the labels are of uh, the string type, so I'm using the string. And so I will just recap that as per our constraint and using the post randomize method, uh, we are expecting that our stimulus will not provide two consecutive writes. It can have two consecutive or lots of consecutive reads, but no consecutive writes. So let's just save the code and check for any compilation error. Okay, there are no errors, so let's just go ahead and run the simulation. So as you can see it right here in the console that our constraint worked perfectly. There are no consecutive write. As you can see that the first stimulus is read, then write, then read, 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 then write, then there is no write after write. So then it is followed by read, write, read, write. So even if I repeat this loop for 1,000 times, I will get the same pattern that there will be no consecutive writes. So that is how uh, to force to use post randomize to avoid getting consecutive write, and it might be useful so for lots of scenarios. For example, for in the case of asynchronous FIFO, in which you have declared that there won't be any consecutive writes and stuff. So I hope you find this video useful and stay tuned for more. Thank you so much.